Great. Thanks for that great introduction. It's a cool space. So as you all heard, I'm Kyle. I'm a NeuroAI scholar at Cold Spring Harbor Lab, where I study the intersection of neuroscience, computer science, and artificial intelligence. So some of you may have heard that term, artificial intelligence or AI, especially if you've been following the news recently. And you may already have some idea of what that term means, but what I want to do tonight is give you a little bit of my perspective on AI research and what I think is important, and then also give you a glimpse of a project that I'm working on at the lab to get an idea of how we research AI at Cold Spring Harbor. So I see a couple of lab members in the audience, but for those of you who aren't familiar, Cold Spring Harbor Lab is a world-renowned biology research institution. They've done groundbreaking work in cancer research, genomics, plant biology, and of course neuroscience, which is the group at Cold Spring Harbor that I work most closely with. So in contrast to all those smart people, I know nothing about biology. In fact, I think the last time I took a biology class was in high school. But that's okay, because all the great neuroscientists at Cold Spring Harbor, they provide the insights from biology that I use for my research, and I collaborate with them, and what I bring to the table is my background in computer science. And specifically what I worked on was building processors. So probably all of you have one of these in your pocket right now, a phone. And inside this phone is a device called a processor, and it's responsible for running everything on your phone, all your apps. And it was my job to design this processor and build it. And I did that during my undergraduate studies and then also in industry. And after a while, I decided I wanted to go to graduate school. And this is because of an observation that many in the field of computer science were making at the time, which is that we were hitting a limit for our ability to build computers in a way that's energy efficient. And this is something that not many of us think about. We kind of take it for granted that our phones will get faster every year, our laptops will get faster every year, and we don't expect our phones to start burning our hands or our laptops to get so hot we can't put them on our lap, right? But the reason that's possible is because computer scientists have been able to make processors twice as fast every year without consuming more energy. But the trend over the last decade has been that that's slowing down. And so a lot of researchers like myself, we were looking into the next frontier of computing, what computers would look like for the next several decades. And so when we talk about doing energy efficient computing, we think about two things, hardware and software. So hardware is the actual device, the actual processor that your apps and your programs run on, and software is the apps and the programs themselves. And so when I was in grad school, I mostly focused on hardware, trying to make it more energy efficient so that your existing programs could run on it without consuming as much energy. But what I work on at Cold Spring Harbor is more on the software side. And the specific kind of software that I focus on are the programs that power AI models that we hear about in the news. There's a pretty simple reason for that. If we look at what programs we run right now on all our computers today, what consumes the most energy, and what will likely consume the most energy for the next several decades, without a doubt, it's artificial intelligence. And so, why does artificial intelligence consume so much energy? To get to that, why don't we talk about ChatGPT? And so many of you might have heard of ChatGPT before, but if you're not familiar with it, it's a type of AI model called a large language model. And what this means is it's a big AI model that's trained on language, trained on text. So it takes in text, and then it produces text that seems like a plausible response into the text that it took in. And so this is what it looks like if you're a user using ChatGPT. You can go to a website and you'll get a chat window just like this, and it'll look like a window that you would use if two humans were talking to each other. But here, instead, whenever I type in something and I hit enter, it takes the text I typed, it sends it to this AI model, and the AI model produces some text that seems like a plausible response to what I just said. And so here's a fun example. I said I want to play a text-based role-playing game where we're going to pretend we're in some sci-fi universe, and ChatGPT is going to be the controller here, and it's going to come up with some scenario and then give me a bunch of options of what to do, and I'm going to say what I think I want to do, and then it's going to respond accordingly. And so it says, sure, let's get started. And it says the scenarios, I'm part of this intergalactic team of humans, and our spaceship crashed on an unknown planet, and and then asked me what I want to do. And the first thing I said is I want to check if anyone's hurt. And it says, sure, you look around, you realize everyone survived, but some of your teammates are injured. And then it keeps going on, and we can play back and forth like this. So this is a fun example of ChatGPT, but this is really powerful technology. It takes a lot to make this work, right? And so if we ask, what is the energy required to get a model that works like this? Well, raise your hand if you drove your car here today. Bunch of people in the room. I want you to imagine yourself at the gas station filling up that car. You do this probably every week, maybe every 2 weeks. It's something we have all have a very real sense of because it affects our wallet. We know exactly how much money we're spending every month on gas, right? And now I want you to imagine yourself filling up gas over and over again the entire time you have their car, right? Your car probably will last you 20, maybe 30 more years. So you're going to fill up a lot of gas over that time. That's a lot of energy it costs to run your car the entire time you owned it. It's a lot of carbon emissions that were created. Spread out, though, over 20 to 30 years. Now, to train one AI model like this, it'll use up 5 times as many carbon emissions, but in the time span of a couple of months, which is how long it takes to build one of these models. And for a company like OpenAI, the company behind ChatGPT, they won't just make one of these models. This is the version you and I see, but they'll do it over and over again. So maybe they're producing the carbon emissions of 20 to 50 cars over the time span of a single year. Okay? So the energy cost associated with these models is immense. But why is that? Well, in order to get a model that works like this, we have to go through a process called training, which is how the model is able to learn how to produce text that looks plausible. So in the example of ChatGPT, I'll give it what's called a training example. So like a sentence, maybe I would say, today I came to work in my blank. And then ChatGPT will fill in the blank with something that's plausible, like car or bike, or it might fill it in with something that's implausible, like octopus. And then we'll tell ChatGPT that's correct, or that's incorrect, and then it's going to adjust itself so that the next time it responds, it'll respond with something that's more plausible. And then we'll do this over and over and over again, and it takes a lot of examples like this before ChatGPT is able to produce sentences that look as good as this, right? And in order to train specifically ChatGPT, it's basically trained on all the text that's out there on the internet. And any kind of wacky thing you have in your head, someone has written about it on the internet. There's a lot out there, and all of it is used to train ChatGPT. So that's a lot of data and a lot of energy that's consumed. Compare this now to you and me. We don't need that much data in order to learn all the things that ChatGPT is capable of doing. When a baby is born, it can open its eyes, it can start to see, it can move its limbs, it can make noises, and pretty quickly, it can start to even recognize objects and crawl around and doing all the things that it needs to do to survive. Why is that? Well, our brains are made up of cells called neurons, and these neurons are connected to each other. And they're not just connected to each other randomly, they have a very specific pattern to their connections. They're very structured, and this is why our brains are able to do all the things that we're able to do. Even as a baby, your brain already has this patterning, and the reason it has this patterning is because we have our genome, our DNA. Evolution has learned over billions and billions of years what's required by all of us, what all of us are required to do as soon as we're born in order to survive, and it encodes that in the pattern of the connections in our brain right as soon as we're born. Compare that with AI. Artificial intelligence also has this concept of neurons. It's not the exact same as the neurons in our heads, but it has these artificial neurons, and they also have connections. And the way it learns to do the things that it learns to do is by adjusting those connections. But unlike us, those connections are totally random when AI first starts out. It has no pattern at all. And this is why it takes so many training examples for AI to be able to do something useful. It has to learn all that information that you and I get for free just through our genome. And so the project I wanted to talk about today is one where we're trying to port this idea of a genome, an idea of having this structured pattern as soon as we start out, to AI models. And the way we're going to do that is we're going to use something called a diffusion model. So this is another type of AI model. You may not have heard the term before, but you probably have encountered it if you've been reading the news. You may have heard of AI models that can create art and draw pictures. And the technology powering those models is a diffusion model. And the way it works is it starts off with noise, picture static like on your TV, and slowly shapes that noise into a signal that we all recognize, the picture that we want to create. So here's an example of a diffusion model. You can see it starts out originally with this noisy looking image, and it slowly turns that image into a picture of a cat, which is what I wanted it to do, right? And so for various reasons, me and my colleagues at the lab, we believe that this kind of model will be really good for taking those noisy connections that are in artificial intelligence and shaping it into a useful pattern of connections that can do the task that the AI model needs to do. And just to give you a visual of what that looks like, here's something that's very similar to our brain, a molecule. And so a molecule is just kind of like our brain. You have a bunch of atoms, and those atoms are connected up to each other. And to think of what a noisy version of a molecule might look like, you can look at the figure on the right. You have a bunch of these dots. They're all clumped together. They're a totally jumbled mess. And then slowly, as we apply the diffusion model, it turns into a molecule which might look like a picture that you've seen in the chemistry class before. And so we're kind of doing the exact same thing with the neurons that are connected inside these artificial intelligence models. We're slowly shaping them using our diffusion model into something useful without seeing any training examples. And so hopefully, in the end, we'll have AI that starts off already being able to do something useful, and then just like you and me can learn how to get to the same performance as ChatGPT without too many training examples. Okay, and so the last thing I wanted to talk about today is kind of circling back to why we're doing any of this, right? If we want to make energy efficient AI, there's one pretty obvious reason for doing that. We just talked about the carbon emissions of training something like ChatGPT. Climate change is affecting all of us. Anything we can do to reduce our carbon emissions is something important to pursue. But there's another equally important reason here, and that's access. Energy is an important resource, and if you have something that costs a lot of energy, then that means that only the people who are the wealthiest will have access to it. And right now, what that means is the only people who can train a model like ChatGPT are companies like OpenAI or Facebook or Google who have a lot of money, right? And if in 10, 20 years, artificial intelligence is going to be an integral part of all of our lives, then it's absolutely crucial that all of us have a say in what AI models do and what they become in the next 10, 20 years. And the first step to making that happen is making sure that everyone has the ability to use and to train AI models. And making them more energy efficient will be a key piece in getting there. And of course, this could help a lot of communities who might have an interest in what AI does. But to round off, I'd like to talk about one specific community, which is all the other scientists at Cold Spring Harbor. Academic labs, we do a lot of cutting-edge research, but we don't have access to the same resources as Facebook or Google, and so we have to do a lot more with a lot less. And we still want to be able to use the latest AI models to analyze the kind of data that all the great scientists at Cold Spring Harbor are collecting. And so hopefully full circle, my research, which will make AI models more energy efficient, will actually end up helping the scientists at Cold Spring Harbor, that we have AI models that are more accessible to everyone, including the great researchers who want to use science to make all of our lives better. And so I'll stop there and thank everyone for listening and open the floor up to questions about what I talked about or anything.